All right, let's continue on then. I've already mentioned the sort method to you and the reverse method to you. You're going to see both of these in just a second. All right, and there's also the binary search. So we're going to look at all of those right now. First one they go through is the binary search. It's the hardest one. The binary search is what's known as a halving search, H-A-L-V-I-N-G, because you get a list and you keep cutting the list in half. Now, I may have told you this last semester. Maybe it's just because I'm a little weird and I find things funny sometimes that other people don't. Okay, I'm watching. This was a long time ago. During the summer, I'm watching an episode of The Price is Right. I have no idea why I'm watching it, but I am. It's back in the day when Bob Barker was the host. He has a guy up there, and he says, you've got 60 seconds to guess the price of this refrigerator. He says, and if you get it, you get the refrigerator, and if you don't, you don't. So the guy goes, $1,000. I put the clock on it. He goes, $1,000. And he goes, higher. No, he said lower. And the guy goes, $900. And he goes, higher. And the guy goes, 901. And I'm thinking, you ain't going to win. Okay? But if, let's assume for a second that he does that. And fridges are more, they're more expensive today. Let's say it's $19.95. Let's just say it is. All right? So I go in there and he says, give me a guess. I say 1,000. And he says, it's higher. I say 2,000. And he says it's lower. So I know the value's got to be between 1,001 and 1999, correct? So I keep taking half of it. So I say 1,500, and he says higher. I say 1,750. He says higher. I say 1,875, and he says higher. Now I've made 1, 2, 3, 4, 5 guesses. And I know that the price has to be between 1876 and 1999. So in 5 guesses, I've cut out a hell of a lot. So I come in here and I keep trying to get about in half. So I say 1930, let's say. And he says higher. Now I know it's got to be between 1930 and 1999. So again, I cut it in half. I say 1960, let's say. And he says higher. So I do it again. And I say 1990, and he says higher. Now by making 1, 2, 3, 4, 5, 6, 7, 8 guesses, all right, I know it's got to be between 1991 and 1999. All right, if I'm playing that game where I have to guess the price of the refrigerator, I'm probably going to win now. All right, so I cut it in half, and I happen to just say 1995, and he says, you've got it. All right, well, the reason I showed you that is that's pretty much how a binary search works. But for the binary search to work, you have to first put the array elements in sorted order. Okay? And also, all it does is it finds the first. So if I've got a list of numbers and I want to know if the number 87 is in there and it's in there 3 times, it only finds the first occurrence. So it's not the best search to use, okay, for everything. But it splits the list in half and it says, is that what you're looking for? No. Is it higher or lower? If it's either way, if it's higher or lower, you've now eliminated half the list. And that's what they're saying right here. That's exactly what happens. Notice what you do. They set up an array called numbers. All right? And they say enter an employee ID. So there are 1, 2, 3, 4, 5 employee IDs. They're in sorted order. So it comes in here and I say 200. So what it does is it says, I want to search this array for the value 200. And in this case, it'll return -1 because it's not in there. So it'll come back and it'll say, ID 200 not found. If I do it again and I say, give me 219, it'll check and it'll say, 219 found at position 0123. That's all the work that you have to do. You know already, I showed you, if I wanted to make, if this array was not sorted ahead of time, all I'd have to say would be array.sort, and then in parentheses put ID numbers. Boom. Then it's going to look like this. Then I can call the binary search on it. Does the concept of a binary search make sense to you? You will have to do a binary search on your next test. Guaranteed. All right? So again, they give an example right here. As I mentioned to you, binary search isn't the best for every time you're going to do a search. First of all, if your array is not in ascending order, it doesn't work. Because you can't keep cutting it in half. It doesn't make sense. Second, if your array holds duplicate values, binary search only finds the first one. So if you want to find how many times something exists in an array, you don't use a binary search. Third, it doesn't work on ranges. It only works for an exact match. So when we looked at that example before, where we said if you bought 0 to 12, you got no discount. If you bought 13 to 50, etc., you couldn't use a binary search for that. But sometimes it's one of the best types that you can use. Now, a regular sort, which is shown on page 248, doesn't have to be numbers. Notice what we're doing here. We got a list of names. All right? Now, you know this because we've talked about this in earlier chapters. If I'm going to do this, I'm probably going to want to make sure that all of this is in uppercase or in lowercase. So I'm comparing apples and apples. But you look at this, if I run this, when I get done, it's going to say what? Mindy, Ned, Olive, Patty, Richard. Okay? Then if I do that, after I did the array.sort, if in the next line here, so let's assume there was a line between this array.sort and the for loop. So I add a new line in here, and I say array.reverse names. Now it's going to hold Richard, see if I can do it right, Patty, Olive, Ned, Mindy. And if you get that, there's no more to it than that. All right? One of the reasons in this language that when you create an array, all the elements have to be the same type is so you can do sorting. Because it wouldn't make much sense if you, like in JavaScript, where I can have a name, and then I can have a date, and then I can have a Boolean, then I can have a number. That makes no sense when you're trying to sort it. Turn this thing off. I've got my... All right. So when I run it, that's what it would look like. And if I did the same thing, but I did the reverse sort, I just mentioned to you what it would look like. I shouldn't have said reverse sort. When you do an array.sort, it puts it in ascending order. If you immediately call array.reverse, then it puts it in descending order. All reverse does is it reverses the list. So if I've got 5 numbers in here that aren't in any order, 31, 8, 43, 71, and 7. All right, if I call sort, it's going to do this. So sort would do this. 7, 8, 31, 43, 71. If right after I called sort, I called reverse, it would now be 71, 43, 31, 8, 7. But if I have this list and I call reverse before I call sort, all it's going to give me is 7, 71, 43, 8, 31. If that makes sense to you, there's no more to it than that. So if you want to actually put something in descending order, you have to put it in ascending order first and then call reverse. And if you get that, like I said, there's no more to it than that. And we're going to be doing that in just a couple minutes. There's another one of these you do it's on pages 250, 251, and 252. All right? Why is that important? Well, if you take a look on page 252, this is the kind of thing we're about to do in just a few minutes. We're going to manually generate 25 numbers. Once we do, we'll show them in their original order, then we'll show them in ascending order, then we'll show them in descending order. Does that make sense? All right. The other thing that you may or may not have realized, as soon as I put it in ascending order, That's my smallest number. As soon as I put it in descending order, that's my largest number. So we're going to take advantage of that too. Plus, we'll use an array and we'll add up all the numbers to give us a sum. And then we'll divide that sum by the number of array elements that we have, and that'll give us our average. All right, so that's what we're going to do in just a couple minutes here. But again, if you're confused on this stuff, I would strongly suggest that you look at the You Do It exercises that are in here. All right. Starting on page 252, they talk about multidimensional arrays. Arrays of more than one dimension. All right. Two-dimensional arrays are the ones that are worked with most often because people can conceive of what they are. When you do arrays, you always do them in a row column order. So the first number that you put in there is the row number. Is there a law that says you have to do that? No. But if you don't do that, you'll be screwing with everybody who's going to use your program. Because in every programming language, the first subscript that you put in there, the first index, is the row. The second one is the column. All right? So again, row 0, column 0, row 1, column 0, row 2, column 0, etc. All right? This is sometimes called, as it says, a rectangular array. All right? In that kind, each row has the same number of columns. You don't have to do that. You can also create in this language what's called a jagged array. We'll get into that in just a second. All right? You can have arrays of more than 2 dimensions. There is no limit. Typically, you don't see them more than 3 dimensions. It's hard to create something you can't envision. Maybe I told you guys about this last semester because I'll always remember this. I was given this talk, and I should have known better because it was near the beginning of the semester, and we were talking about arrays, and I told the students to go home over the weekend. It was on a Friday like this, and I said, now I want you to go home and draw a 4-dimensional array. And I had people coming up to me. I had people emailing me over the weekend. I don't understand what 4 dimensions looks like. It's like, it's a joke. Wasn't a good one, but it was a joke. All right? So you can have as many dimensions as you need in order to solve your problem, whatever your problem happens to be. There they show some examples. Notice that each set is within its own set or sets of curly braces. It gets confusing. Also, and I think we talked about this before, if I have if I have an array that's called tests, and it has 50 rows, and it has 30 columns, how many elements are in that array? 1,500. You always multiply the row by the column. All right, so this would be 0 to 49, that would be 0 to 29. Again, as I mentioned to you a little earlier, C#, like other programming languages, they're not the only one, but C# supports jagged arrays. It's easier to show it to you than it is to explain it. With a jagged array, notice how each row can have a different number of columns. And that's exactly what a jagged array is. It's a one-dimensional array where each element is another array. So it's an array within an array. All right? So notice it's a 2-dimensional array, but each one is an array, and this one has maybe 10 values, 2, maybe 7, 6, and 2. That's totally legit to do that. Why would you ever want to do that? Well, not there. But they do mention here on the top of the page, get that up. All right. That creating a jagged array sometimes offers you the best option when you've got a very complex problem to solve. Let's suppose that in this class, the way that it was set up, and it's not like this, but let's pretend for a second that the way that it was set up was it was all independent study. All right. In fact, give you a better example. I'm not making this up. I've got two friends who, at the place I used to work at, they both went in for tests. They wanted to get certified. They wanted to get a network certification. Make sense? So they went in to take this test. The first guy went through 10 questions and got all of them right. Okay? And instead of getting an 11th question, just got a message back saying, congratulations, you are now Cisco certified. All right? The second guy missed question 6, so that he had to answer a whole bunch more questions to show he still had that knowledge. He passed also, but he took about 50 questions. They drilled down with him to make sure he understood it. The reason I'm telling you that is you could do something like that using jagged arrays. All right? There will be nothing on your test about a jagged array. There'll be nothing on your test with multi-dimension arrays. All right? So the last thing that's in here on pages 258 and 259 talks about issues that you can have with arrays when you work with GUI programs. And it says the major unusual consideration when using an array for a GUI is that the array values change based on user input. So the array must be stored outside of any method that reacts with the user's event. What? In English, what that says is normally if you're going to have an array in a GUI program, you make the array global. You declare it outside of any method function that's in the program so that you can play with it, change it on an as-needed basis. And they show you an example in figure 624 that's on the top of page 259. So notice they've created the array outside of any one of the methods that are underneath it. All right? And that pretty much is it. So let's turn up to page 261, if you would, in your books, and let's take a quick look at the review questions. All right? Number 1. In an array, every element has the same. The answer is data type. All right? They're all ints, they're all floats, they're all whatever. So number 1 is B, data type. Number 2, and this one is on the test, I know. The operator used to create objects is C, the new operator. So number 1 is B, number 2 is C. Number 3, which way do you declare an array of 6 integers? The answer is D. Int bracket bracket array equals new int 6. So numbers 1, 2, and 3 are B, C, and D. Number 4, the value placed within the square brackets is known as, the answer is actually D. It is known as a subscript or an index, but it must always be an integer or a variable that holds an integer value. All right, so number 4 is D. Number 5, if you define an array to contain 10 elements, the highest subscript you can use is C, 9. So number 5 is C, 9. Number 6, initializing an array in C# is B, optional, because if you don't initialize it, as I mentioned to you earlier, it'll be pre-initialized for you. So number 6 is B. Number 7, when you declare an array of 6 double elements but provide no initial values, the value of the first element is A, 0.0. Number 8, which of the following correctly declares an array of 4 integers? Good, bad, or indifferent, the answer is D, any and all of these. I would recommend always doing it like C, but you don't have to. Number 9, when an ages array, so you put 4 ages in here, 20, 30, 40, and 50. Ages sub 1, That's ages sub 0. So ages sub 1 is 30, and 30 is C. So number 9 is C. Number 10. When you create an array like this, what is ages 4? The answer is D, undefined, because that's ages 0, ages 1, ages 2, and ages 3. There is no ages sub 4, so its value would be for 10, D, undefined. Number 11. When you declare an array as in temperature, the length would be, so how many elements are in here? 1, 2, 3, 4, 5, 6. So the answer to 11 is B, 6. Number 12. Which of the following doubles every value in a 10-element integer array? Okay? Now, when I first did this, I thought, well, it can't be B, but I'm not. Notice what the array is. The array is the word amount, correct? The array here is the word amount. I'm not changing the value in amount here. I'm changing the value in number. So the answer, the correct answer for 12 is C, both of these. 12 is C. 13. Which of these adds 10 to every element in the array? Well, you can't use B for number 13 because if you remember, you can't change the values in the array itself. So number 13 is A, the for loop in A. Number 14, two arrays that store related information, they are D, parallel arrays. That's the one I showed you with first name, last name, and salary. Number 15, assume an array is defined as shown. Which of the following would display the array in reverse? The answer is B. The first one's wrong because there's not 4 elements. So A would have to be wrong and D would have to be wrong, which leaves just these two. All right? If I used C here, then it would go 3, 2, 1, 0. No, it would just so 3, 2, 1. It would only do 3 of them. If I do greater than or equal to 0, it'll do 3, 2, 1, 0 or 3, 2, 1, 0. Number 16, assume an array is defined as shown. Which of the following would place the array stuff in descending order? The answer to 16 is C. You'd have to sort it first, then run reverse on it. Number 16 is C. Number 17, which traits do both of these types of sorts have in common? 17. The answer is B. They both belong to the system.array class. 17 is B. 18. If you use a binary search and the object you seek is not found, typically D, a negative value is returned. In fact, it's usually -1. 19. The binary search method is inadequate when B, the array holds duplicate values and you want to find them all. 19 is B. Number 20. Which of the following declares an array with 8 rows and 5 columns? The answer is D. Anybody need any of those repeated? Then if you would please, I emailed this to you yesterday. Take out your test review. So this is the study guide you have for Chapter 6. All right. So question 1, arrays, there's 3 questions in here. Everybody see that? There's 3 questions. So these are 3 different test questions for number 1. Arrays are useful when you need to store multiple values. So number 1, the first part is multiple. Second, an array elements are automatically numbered beginning with element 0. And elements in an array are denoted by either an index or a subscript. Let me get rid of that, sorry. Yeah, come on. All right, so number 1 is multiple, 0, and subscript or index. Number 2, what is the C# operator that you use? I'm trying to move that over, but not that much. To create an object, so number 2 is the new operator. Number 2 is the new operator. Number 3 also has 3 questions on it. When you declare objects, character fields are initialized to null, booleans are initialized to false, and numbers are initialized to 0. So number 3 is null, false, and 0. Number 4, that thing is called an initializer list. So number 4 is initializer list. Number 5, you can iterate through an array if you go from 0 to the array length minus 1. So number 5 is 0 to array.length minus 1, or from 0 to less than array length. Number 6 has 2 different questions on it. The first one is for each, and the second one is called iteration variable. For each and iteration variable. Does everybody have the first 4? Bless you. Everybody have the first 4. All right, I'm going to move it down then. Number 7, what is a sequential search? It's a search in which each array element is examined in order. You've got to go through all of them in sequence. So number 0, then number 1, then number 2, etc. You have to go through them all. All right. Number 8. Well, look, I didn't do number 9. Number 8. You should put the most common items first when you're doing something like this. So the answer to 8 is most common items first. I'd probably figure out 9, but let's see if I actually have it on mine. Nope. All right. So number 9. What C# array method can be used to find the first? Oh, you know what? I bet you it's down here. There we go. So what C# method can be used to find the position of a requested value in the array? The answer to this one before the first question mark is the binary search method. Second, which one can be used to arrange them in ascending order? That's the sort method. All right, the user passes the array name to array.sort. And which one puts them in opposite order? And that's reverse. 4 questions on this. So the answer to the first thing by the first question mark is binary search. The second one is sort. The third one in this thing here would be array.sort. And the fourth one, that should have been a question mark, the fourth one is reverse. Everybody have all 9 of those first ones? Anybody need any of the first 9 repeated?
I need 1.
Multiple, 0, and subscript or index. Anybody else? Any of the first 9? Going, gone. All right. Number 10. An array which has a single column of values is known as a single dimension array. So number 10 is single dimension, and typically you'll see it put in with single hyphen dimension. Don't have to, but that's usually the way you see it. Number 11, when an array has the same number of rows and columns, it's a rectangular array. So number 11 is rectangular. Number 12, or the other part of 11, is jagged, when the columns can have different lengths. So 11 is single dimension. Try it again. 10 is single dimension. The first part of 11 is rectangular. The second part of 11 is jagged. Number 12, the array must be stored outside of any method that reacts to the event. In other words, what they're saying here is global. So number 12 is global. Number 13, you already got that question earlier. A subscript or index is what you put in the brackets. You already heard that in an earlier question. So number 13 is a subscript, also known as an index. Number 14, all C# arrays are derived from the system.array class. 14 is system.array. 15, what is an initializer list? It's a list of values provided for an array. They go within the curly braces. All right? Anybody need anything from 1 through 15 repeated? I'll leave that up there for just a second. All right, number 16. Which C# system.array property holds the array length? It's the length property with a capital L. Number 17, what's a parallel array? It's an array with the same number of elements. Again, it's like I showed you with the first name, last name, and salary. They can be of different data types, but they have to hold the same number of elements in each array. Everybody has the first 17 now, correct? All right, here's the definitions. I'll leave them up kind of big like that and then just move them in just a second. It's because there's 9 again, and here's the first 6. So please look at this, because notice one says 0 and one says element 0. Very easy to mix the two of them up. 0 is the default value for an array's numeric field. Element 0 is the first element in the array. If you mix these up on the test, they're wrong. Because 0 is not the first element in the array, it's the 0th element. And element 0 is not the default value. So if you mix these up, you will lose points. It's not a threat. I'm just telling you because I want you to put the right answers down. Everybody have those first? 2, 3, 4, 5, 6. Yes? So again, Monday will be a lab. Tuesday, we will take the written test, and then we will go on into Chapter 7. Questions on that? So since Monday's a lab, let's look at what your homework assignment will be from Chapter 6. I'll let people finish up what they're doing right now, and once you're finished up, please, if you would turn up to page 265. Does everybody now have all of these? Anybody need any of them repeated?
The last one is 17.
Anybody need any other ones repeated? All right, I'm going to go back to the book then and turn to page 265. All right. You have 4 problems I'd like you to do for Chapter 6. From page 265, 1 and 4. And from page 266, 7 and 10. 10 will make you think. You're, for lack of better words, you're almost doing a game of hangman. All right? Number 1 says, write a program named array demo that stores an array of 8 integers. Until the user enters a sentinel value, you make that sentinel value up, whatever you want it to be. You give them 3 options. If they put in a 1, all right, they list the array from first to last. If you put in a 2, they go from last to first. If you put in a 3, you choose a specific position to interview. Number 4 is very similar to one of the program examples in the book. All right? Write a program named check zips, where you've got an array with 10 zip codes, and prompt the user to enter a zip code and then display a message telling whether or not that zip code is in the list. On page 266, number 7, works with the Whippet Bus Company. So you put in the trip distance and it tells you how much your ticket price is going to be. Again, it's similar to one that's in the book. So if you get confused, I would go back and take a look in there. Number 10, which actually goes on to the next page also, it says create a game similar to Hangman called Guess a Word. I'll let you read that yourselves, but on the next page they show an example of what it should look like. All right, I've given this assignment before, and sometimes people literally like to, if you miss the first letter, they'll do this. You miss the second letter, they'll do this. The third letter, they'll do this. Fourth letter, fifth letter, sixth letter. And they'll actually draw a little stick figure. You don't have to do that. If you want to do that, you can. This is just an O. That right here, this big thing, that would be a pipe sign for the body. That would be a backslash, a forward slash, a forward slash, and a backslash. If you want to do that. Again, you do not have to. Questions on anything that we've gone over today? All right, then what I'm going to do, it's been 40 minutes, okay? What I'm going to ask that you do is start up a brand new console problem or a program, and we're going to call this, yeah, it's a stupid name, but it's the one I always use. We're going to call this program, this is one word, Array Fun Console. Array Fun Console. One word. Save it wherever. You're not turning this in. Everybody hear that? You're not turning it in. My hope is by going over this, this will help you. All right? I've already got an Array Fun Console, so I'm going to right mouse click, start up Visual Studio 2015, and I'm going to File, New, Project. It will be a console project, and I'm going to make it Array Fun 2 console. Okay? So once we get going, we'll have this. Is that where everybody is? All right. What I'd like to do is I don't want to go for 10 or 15 minutes and then give you a break. So what we're going to do is let's just take a break now. We'll come back at 10 after, and by 10:30, we should be finished with the program. 20 minutes should be enough time. All right? So again, come back please at about 10 after is fine.